America. It started with a dream that captured the imagination of millions around the world. Inspired by hope, people came to America determined to build, and build they did. With hard work, courage, and skill, American craftsmen helped transform a vast wilderness, providing shelter for families and businesses, and they also passed on their knowledge and experience to newcomers. And today, that legacy continues. Craftsmen in every trade teach apprentices time-honored skills that will always be in demand.
Hello, and welcome to this National Roofing Contractors Association's program, Application of Single-Ply Membranes, another in the Roof Application Training Program series.
Today, you're going to become familiar with the components and materials professional roof mechanics use for applying single-ply systems, including loose-laid ballasted, mechanically attached, and fully adhered systems. You'll learn how to apply different ballast materials and membrane surfacings. Installation of flashings for these systems will be covered in a future program.
You'll also get an opportunity for hands-on experience during your in-shop and on-the-job training sessions. Keeping in mind our motto, roofing is what we do, safely is how we do it. Let's begin.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
A man did land on the moon, and behind those first steps stood a great number of trained experts. They were professionals from many different backgrounds who built on a solid foundation of knowledge pioneered by earlier generations. After years of effort and hard work, the American space program soared into a new age of exploration.
Americans have always known that a grasp of the fundamentals makes it easier to succeed. In part one of this video, you're going to learn some important new skills. If you recall, there are 3 tried and true systems for installing single-ply membranes: loose-laid ballasted, mechanically attached, and fully adhered. You also need to pay particular attention to materials used for these installation methods and learn about different specifications you'll find on the job. Okay, you ready to begin? Let's blast off.
For a loose-laid ballasted system, a waterproof membrane is often installed over a substrate of rigid insulation board. It may also be applied directly to certain roof decks. The membrane gets mechanically attached at the perimeter edges and around penetrations. Then, flashings are installed, and all seams are sealed. Some specifications, or specs, call for a filter fabric or protection mat to be applied over the top of the completed membrane.
The next task is to install the ballast. But what exactly is ballast, and how does it work?
Ballast is the primary anchoring material for this system. It uses its weight to hold a membrane in place. But here's where it gets tricky. Ballast can be very heavy, and not all roof structures can support the system load. So, a competent person should determine the roof structure's load-bearing capacity. One variation of traditional loose-laid ballasted systems is a protected membrane roof, or PMR. In a PMR, the membrane is first applied, and then an extruded polystyrene, or XPS insulation, is installed over the top of the membrane. A filter fabric may be installed before the ballast material is placed over the top of the insulation. Generally, a ballasted membrane does not get any other surfacing, except possibly on exposed flashing areas. Now let's take a look at the mechanically attached system. Again, a waterproofing membrane is laid over a rigid insulation substrate, slip sheet, or protection layer. In addition to attaching the membrane at perimeter edges and around penetrations, fasteners are used to hold the membrane in place along the seams throughout the entire field of the roof. The fasteners are typically installed through the membrane in a specific pattern along the side lap edges. The flashings get installed and the seams sealed. Occasionally, a liquid-applied protective coating is added to surface the membrane. The fully adhered system is held in place just as its name suggests. The field membrane is adhered, fully using an adhesive that bonds it to the substrate. The membrane is still mechanically attached at the perimeter edges and around penetrations. Again, the flashings are installed and seams sealed to complete the application. Sometimes liquid-applied protective surfacings are also added.
You will learn how to install single-ply membranes using all three of these methods later in this program. Right now, though, let's look at some of the materials you'll use to install these systems.
A slip sheet or protection layer is applied between the roof deck and the other components. A slip sheet helps prevent materials from sticking together, and it protects a membrane against damage by an incompatible or rough substrate. A slip sheet may also minimize damage caused by abrasion. A membrane, as you know, keeps the building watertight. A splice wash, or splice primer as it's sometimes called, is a solvent-based liquid that's used to clean certain membrane seams. When you use a splice wash, wear rubber gloves and eye protection. Chemicals can be harmful if absorbed through skin. If you use a splice wash in a space without proper ventilation, you may also need to wear a respirator. Seam tape is used to bond two layers of some thermoset single-ply membranes. Seam tape is a non-reinforced, self-adhering double-sided black tape with a craft paper or plastic peel-away surface. Today, seam tape is the most common material used to bond seams of EPDM thermoset membranes. Another material you may use is splice adhesive. It's solvent-based and used to bond thermoset single-ply membranes together. As with any chemical, it's recommended that you wear gloves and eye protection when handling splice adhesives. Again, you may need to use a respirator in a poorly ventilated space. In-seam sealant is placed on the innermost edge of the bottom layer in some seams or splices. It prevents moisture from entering the seam bond from underneath. Usually, in-seam sealant is only used with liquid-applied adhesives. A bonding adhesive is most often used to adhere single-ply membranes to a substrate. It is not used to bond membrane to membrane. It's also used to secure membranes at perimeter edges, around penetrations, and for vertical flashings. Lapse sealant is placed on the outer edges of some membrane seams or splices. A lapse sealant helps prevent moisture from seeping between bonded pieces or into exposed membrane reinforcement fibers. There are a variety of fastener types with different metal and plastic bars, plates, and strips that are used to attach a membrane to a substrate. A water block sealant is used to tie off between the substrate and a new membrane. It helps prevent moisture from leaking under the newly installed system. A water block sealant is also used to seal a membrane at interior roof drains, some penetrations, and the tops of flashings. Filter fabric is another material included in some single-ply installation. Filter fabric is a fine cloth-like material that is applied before the ballast to help prevent smaller pieces of aggregate from settling between insulation joints. Professional roof mechanics often install special design ballast retention guards around drains, flashings, and perimeter edges. These perforated guards allow free water drainage and at the same time prevent ballast from slipping or washing off the roof surface. Ballast consists of either aggregate, concrete pavers, or a combination of both. Aggregate used as ballast is often called number 4 aggregate. The gravel is graded from approximately 3/4 of an inch to 1.5 inches in size, and larger sized aggregate may be used on certain roof areas in high wind regions. A crushed stone aggregate is occasionally used and usually requires a protection mat as well. Pavers are concrete slabs that come in a variety of sizes. Some interlock, and many have built-in standoff lugs that allow water to drain underneath. Some pavers are set on small plastic pedestals to keep them off the membrane surface.
As you've just seen, there are many different materials available to install the 3 types of single-ply roof systems. And you should be aware that there are different specifications for each. Always be sure you're familiar with the specs. If you don't understand any part of a system's specs or have any questions, ask your foreman.
Each single-ply roof system requires a certain type of membrane with or without reinforcement and may call for different sized rolls. Ask yourself, which seaming method does the system require? What kinds of materials are needed for seaming? Different fasteners are going to be required for different systems. Spacing patterns at perimeter edges and penetrations will vary with type of membrane, wind uplift requirements, and deck type. Check the specs with your supervisor for the sheet layout. Again, always ask yourself, what are the requirements? You'll need to know which temporary night seal procedure to use, depending on the type of membrane and substrate. You'll also need to know the type and quantity of ballast materials to be applied after the membrane has been installed. They can differ from system to system and region to region. A high wind area, for example, may require a different ballast spec than a normal wind area.
That brings us to the end of part 1. Let's quickly review what you've just learned.
You looked at a loose-laid ballasted system and how the weight of the ballast holds the membrane in place. You checked out a protected membrane roof, or PMR system, a variation of loose-laid ballasted. You also saw the basics for application of mechanically attached and fully adhered systems. Remember, complete flashings and seal seams as your work progresses. And you became familiar with the different materials needed on the job. When someone asks you to get a fastener or other component, you don't want to make 3 trips to get the right one. Finally, you saw how different systems have their own specifications that explain how each component should be installed. Remember, if you have any questions about the specs, ask your supervisor. Success can be measured in many different ways, and it's up to each one of us to decide which dream to reach for.
If you think about it, steadily building on the skills you've learned makes the most sense to help you get where you want to go. Speaking of getting somewhere, see you in part 2.
The Statue of Liberty, a great American monument that just about everybody recognizes. All over the country, monuments big and small help us remember what's important. Sometimes they just remind us that life can be good. A well-constructed roof is a kind of monument too. It honors the hard-working, skilled craftsmen who constructed it.
In part 2 of this video program, you're going to learn how to perform a membrane layout. And these skills will serve you well whether you're installing a small roof or one that's monumental. Let's get started.
What exactly is a membrane or sheet layout? It's simple. A sheet layout means the positioning, progression, and direction in which a membrane is applied over an entire roof. You also have to think about the best width and length to use for each continuous run of membrane. Your goal should be to minimize field seaming, yet maximize the performance of the membrane system. You need to take into account several factors, including the direction of the slope, the size and location of the penetrations, locations of interior and exterior drains, wind factors for the area in which the building is located, and the building's use and design features like overhead doors. You also need to consider available roll sizes and the manufacturer's recommendations for the membrane's installation.
A sheet layout is generally designed for the building on which the single-ply membrane is going to be installed. Let's look at an example.
This layout calls for 5 20 by 100 foot rolls in the center area of the roof, 2 50 by 100 foot rolls to finish the center area, and 2 50 by 200 foot rolls for the ends of the roof. Smaller sheets are needed in the center area to work around all the penetrations. It's usually more difficult to do that with larger sheets. Larger sheets are generally used in loose-laid ballasted systems. Now, in this layout, notice the smaller-sized half sheets all around the building's perimeter. A half sheet increases the number of fasteners used to secure areas more vulnerable to wind uplift, like a perimeter edge. The remainder of the field calls for 9 5-foot wide by 100-foot long rolls to cover the larger area, and 4 5-foot wide by 50-foot long rolls to cover the smaller area. Layouts with smaller sheets, and especially with half sheets, are generally used in mechanically attached systems.
If that seems like a lot of information, don't worry. Your foreman will explain the sheet layout's design for you. What's important right now is knowing how to follow and install a sheet layout. Let's see how it's done.
Typically, you will begin the installation at the low end of a roof. Make sure the substrate is sufficiently clean, smooth, and dry. Measure and mark the substrate with a grease pencil and chalk line so the first sheet is set squarely and parallel to the closest perimeter edge. Now, unroll and spread out the first sheet following the chalk line until it's laid out smooth and straight. Fluttering the sheet up and down can make it easier to move. Here are a couple of important safety tips. When you move large or heavy rolls on a roof, don't lift. Instead, use a dolly-type roll carrier. Also, you don't want to pull backward on any materials when you are within 10 feet of the edge of the building. You'd be surprised how easy it is to fall backwards. Instead, stop pulling out the sheet at least 10 feet away from the edge and lay it down. Mark the substrate at this edge of the sheet, and measure the distance remaining to the perimeter edge. Add any extra length to allow the sheet to extend up a wall or over the outer edge. Next, measure this distance back in the opposite direction onto the sheet. Mark the surface of the sheet. Pull the edge of the membrane back and fold it over itself until it reaches the new marks. Go back and grab the sheet at the new folded edge and keep pulling it out, setting the sheet down where it lines up with the marks you made on the substrate. Now, walk over the sheet, turn, and face the perimeter edge. Lift the free end of the sheet and work it out to the edge, letting it flop into place. Finally, to keep this procedure as safe as possible, a competent safety monitor should maintain line of sight and earshot contact when you're working within 6 feet of any roof edge. Remember to check the specs. Some manufacturers may require that you allow the membrane to relax before it's secured. Also, you may have to set temporary ballast, like small spot piles of aggregate, smooth clean tires, wood planks, or sandbags, to hold the loose membrane in place until the proper ballast can be applied. If you do use heavy materials like this, don't set them near seams or closer than 6 feet to any exposed roof edge. Now, apply the rest of the sheets following the layout plan. Side laps and end laps are usually set so water flows over them and doesn't buck the seams. Align each sheet so the side laps properly overlap and follow the lap lines. If the membrane does not have lines indicating the side lap, carefully measure and mark the amount of overlap, about every 10 feet, per the manufacturer's specs. Adjust the sheet as needed to align it with the marks.
Sometimes, installing a membrane around penetrations can cause wrinkles and buckles. Here's a tip to help you avoid this problem.
If the penetration is less than 3 feet wide, tuck the membrane against it, mark the membrane where it meets the penetration, then lay the membrane back down and cut it so it fits snugly around the penetration. When you make these cuts, always be aware that the membrane might be required to extend up a vertical surface or down over the edge. Check the manufacturer's specs for details.
If you need to fit membrane around a larger penetration, here's what to do.
Roll the membrane against the penetration, mark the membrane and pull it back to make the cut. Then fold the membrane back and around the penetration. Realign the sheet and continue to roll it out. It's critical that the seams are clean before they can be sealed. Often the seams get adhesive on them or become dirty during sheet application. So it's a good idea to complete all field seaming as the work progresses to keep out dirt and debris. A tie-off is done at the end of each day where the perimeter edges of the new membrane tie into unfinished sections of the field. A tie-off is a vulnerable area, so it's important to do it correctly. Finally, try to complete all flashing by the end of the day, including application of water block sealant where required around penetrations and edges.
Flashing application is a subject we'll come back to in a future program. Right now, though, we've come to the end of part 2. So let's take a moment to review what we've covered.
First, you learned what a sheet layout is, and then saw how to apply one efficiently and safely. We also saw how to temporarily hold a loose membrane in place on windy days, tackle challenges like fitting membranes around small and large penetrations, and protect a finished membrane from water penetration by doing a tie-off at the end of each day. And don't forget, flashings and seaming should be completed as the work progresses.
You're doing a great job. Keep up the good work. And join me in part 3 to learn how to apply the loose-laid ballasted system.
At the Chicago World's Fair in 1893, a historic moment occurred: the introduction of the first hot dog. It fast became a favorite and whetted America's appetite for more authentic and tasty foods. In Philadelphia, you'll find people lining up for a cheesesteak. In Louisiana, an oyster po' boy makes mouths water. And all over the country, burritos and tacos are tops. Americans have learned to take the best recipes from around the world and recreate these delicious foods right here at home.
It's definitely a lot more complex to install a loose-laid ballasted system than it is to build a perfect garden on a bun. But in part 3 of this video, you'll check out the step-by-step procedures for installing a loose-laid ballasted membrane. You'll also learn to identify different kinds of ballast materials and to apply them safely. Plus, you'll check out a basic paver application. If this seems like a lot to learn, remember, it's a recipe for success.
To begin, the deck should be clean, smooth, and dry. Sweep it clean, remove any sharp objects and debris, and make sure it's completely dry. If you spot any rotted or defective areas, report them to your supervisor. Don't ignore these problem areas. The specs may first call for a slip sheet to be installed. This fabric is rolled loose-laid over the substrate, typically with 2-inch side laps set so they don't buck water. The fabric is trimmed loosely around penetrations and often turned up vertical surfaces. Typically, no fasteners are installed. The single-ply membrane is then laid directly over the prepared substrate. Cut and fit around the penetrations as you go. On windy days, remember to lay temporary ballast materials to hold the membrane in place until you can finish the area. It's also important to complete mechanical attachment at penetrations and perimeter edges as the work progresses. However, if the manufacturer requires the sheet to first relax, then you have to wait the specified period before securing the membrane. Flashings are then completed at all penetrations and perimeter edges. In addition, many loose-laid ballasted systems require installation of ballast retention accessories. Whether the system requires seams to be sealed by hot air welding, adhesives, or seam tape, it's critical that all seams are sealed and checked with a seam probe prior to application of the ballast. And it's best to do this throughout the day as the work progresses.
You have the membrane laid, relaxed, seamed, and flashed. Now it's time to apply the ballast. Here's how.
Ballast, you'll recall, uses its weight to hold the membrane in place. There are 2 basic types of ballast materials: large aggregate and concrete pavers that also provide a smooth walking surface. If specified, a filter fabric may first be installed. Roll out these materials over the finished membrane and provide some temporary ballast to hold the fabric in place. Apply the fabric with side laps to make sure dirt and debris don't penetrate the fabric seams. When spreading aggregate, it's important to protect the finished substrate and membrane from heavy equipment or wheel damage. Use sheets of plywood cushioned with a thin layer of insulation material, especially at aggregate loading areas and frequently used access pathways. Now, check the membrane specs for the necessary ballast rate of coverage. Once you know that, spread the specified quantity of aggregate over a pre-measured 1 square area of the roof to evaluate the thickness and evenness of your rate of coverage. Once you establish your rate of coverage, start spreading the aggregate at the point furthest from the roof loading area. Spread in straight, parallel, and overlapping rows, working the carts back and forth. Follow the same pattern until the entire field of the roof is evenly covered. A word of caution, though. Try not to exceed the specified rate of coverage. The building may not be designed to support the additional weight. All jobs usually require spreading some aggregate by hand. You can move aggregate around the roof with a wheelbarrow. Dump it in small piles, then carefully spread it with shovels or rakes with the tines pointing up. Be careful not to scrape or puncture the membrane. If you do, don't cover it up or ignore it. Report the damage to your supervisor so it can be repaired right away. You may also use hand-pushed or powered aggregate carts, also called ballast buggies, to spread larger amounts of aggregate more quickly. These carts can be very heavy when loaded, so be careful not to damage the substrate when moving them around. Make sure you read and follow the equipment manufacturer's operating instructions before you use equipment like this. Also, never use powered equipment within 10 feet of the roof's edge, in front or behind you. You'll find power carts often get filled from a hopper. The cart fits under the filling spout like this. The hopper is kept full by a conveyor system or crane with an aggregate bucket. Pavers are sometimes installed together with aggregate ballast and used as walkways around mechanical equipment.
One more tip. If possible, don't move equipment or aggregate carts over ballasted areas. It could damage the membrane. Now, let's move on and learn how to apply a concrete paver ballast.
Check the specs to see if you must first install a protection mat or filter fabric over the membrane. Unlike an aggregate ballast, start your paver installation as close as possible to the side of the roof where the material access point is located. Concrete pavers are generally installed squarely to a roof's major wall or exterior edge. To install them, measure out from a wall at equal distances along its length, and snap a chalk line parallel to the edge so you have a straight line to follow. Once you've begun your paver installation, you can build out a smooth, protective walkway over the membrane. Abut pavers tightly or with a specified gap. Check the specs to see if a gap is required. If the wall is not straight or runs on an angle, you may have to cut the pavers to follow the wall's angle. Pavers are cut by powered saws fitted with masonry cutting blades. Never operate this kind of equipment unless you have been properly trained. If you are qualified to work with a saw, you must wear appropriate personal protective equipment, PPE, including face and ear protection. Some pavers are designed to interlock or have patterned edges. Generally, pavers don't fit tightly around penetrations. A piece of preformed foam expansion joint material may be used as a cushion between pavers and vertical flashing. As we saw a moment ago, some pavers interlock by connecting their specially designed offset edges and following a specific pattern. If you install this type of paver, make sure you follow the manufacturer's instructions for properly locking them together. A paver often comes with a separate plastic support called a pedestal, or with standoff lugs molded to its bottom. These hold the paver off the membrane surface and allow water to drain more freely. Extruded polystyrene installation, bonded to lightweight concrete, forms another kind of ballast paver. These paver boards lock together to form a smooth surface and are typically used in PMR applications. Earlier in this program, you saw the protected membrane roof, or PMR system. The skills required for installing a PMR system are the same as for the loose-laid ballasted system you have just learned.
The difference is the order in which the system components are installed. In other words, it's all in the specs. Make sure you follow them. That brings us to the end of part 3. Let's take a moment to review what you've learned.
First, you saw how to install the ballast, taking care to protect the membrane and substrate from damage. Then you learned how to apply aggregate safely and efficiently. Finally, you checked out how different types of concrete pavers are installed.
You're doing a great job. Keep up the good work. And join me in part 4 to learn about mechanically attached installations.
Americans like being on the move. We've always been that way, from single horsepower and motorized carriages to sports cars, trucks, and motorcycles. The American drive to keep moving has meant the development of some pretty interesting means of transportation. If you think about it, a machine like this is a marvel of technology and workmanship. Hundreds of parts must work together seamlessly. It's solid engineering and skill at its best.
In part 4 of this video, we're going to learn how to install a mechanically attached single-ply membrane. We'll also learn about the materials you'll use and the specs required for a typical job. Ready?
As with all proper membrane installations, begin with the substrate preparation. Be sure the surface is smooth, clean, and free of any sharp objects and thoroughly dry. If the specs call for a slip sheet, you will install it first over the prepared substrate, just as you saw for the loose-laid ballasted system. If you recall, single-ply membrane sheets used for mechanically attached systems are typically more narrow than those used for loose-laid ballasted, around 5 to 10 feet wide. This means there may be more individual rolls to lay out, but the layout of the first sheet is the same. It must be squared parallel to the nearest perimeter edge and started at the low point of the roof. To comply with wind uplift requirements, the sheet layout may require narrow or half sheets be installed 1 or 2 rows in from the perimeter edges. That means more fasteners are installed near the edges, where the membrane is more vulnerable to damage by strong winds. You should complete all membrane fastening by the end of each day's work. Once the first sheet is set, start fastening along the sheet's edge on the upslope side of the membrane. Make sure you understand and follow the system's guidelines for the type of fastener and its proper spacing. A fastener should have adequate holding power. Your supervisor will check a fastener's strength with this pull-out tester. It measures how many pounds of pressure the fastener will hold before it's pulled loose. Fasteners with stress plates must be set an appropriate distance in from the edge of a seam. Stress plates must be set right side up and spaced on center as per the specs. Some mechanically attached systems use a bar, properly located and fastened, over the top of a membrane. Then an additional strip of membrane gets installed over the bar. All fasteners must be properly set, not over-tightened or under-driven. And make sure you drive fasteners vertically straight to the substrate, never at an angle. If a fastener doesn't grip properly, remove it. If you don't, the loose fastener may work its way out and puncture the membrane. Pull the fastener out, repair the puncture, and move it over to secure it again. Continue installing the membrane until the entire roof is covered, following the sheet layout. Many membranes have lap lines to help maintain consistent sheet overlap distance. If the membrane doesn't have these lines, you will have to measure and mark your own. Adjust the sheet as necessary and mark the edge of the side lap about every 10 feet using a marking pencil. The next step is to complete all seaming and flashing, just like the loose-laid ballasted system. Seam directly over the fasteners because they should be fully covered by the overlying membrane. The seams should be clean, so get the seaming done as quickly as possible. That way, there's less time for dirt to collect. Most likely, you will need to protect the completed portion of the system from water damage using a temporary tie-off. Whatever method you use, just make sure you keep the water out of the newly installed area at the end of each day's work. The final step may be the application of a protective surfacing. These skills will also be taught later in this program.
Well, that brings us to the end of part 4. Before we move on, let's quickly review.
First, you saw how mechanically attached systems are held together, and how to properly space, set, and secure the fasteners. Seam laps should completely cover fasteners and be completed as the work progresses. You were also reminded how important it is to follow the specs when you install a mechanically attached membrane. If there's something you don't understand, always ask your supervisor. Practice what you learn, and I'll see you in Part 5 for fully adhered installations. New York, the Big Apple, a city that never sleeps. Everything's brighter, faster, and bigger. It's always been like that. On May 1st, 1931, for instance, the Empire State Building opened for business. At 1,454 feet, it was the tallest building in the world. It took years of careful planning, revolutionary construction techniques, and 7 million man-hours of labor to complete. Today, thanks to the innovative thinking of its builders and the sound engineering principles they employed, this famous landmark continues to attract the curious from all over the world.
No matter what size structure you happen to be working on, craftsmanship and attention to detail are also keys to your success. If you learn and practice the principles in this video program, each roof you help create will also stand the test of time. So, get ready. In part 5 of this video, you're going to learn another critical skill: how to install a fully adhered single-ply membrane.
Once again, your first task is to make sure the substrate is smooth, dry, and free of dirt, sharp objects, and debris. A clean substrate is critical to a successful installation. Slip sheets are usually not installed in a fully adhered system. Instead, the membrane is bonded directly to the substrate, typically a rigid insulation. Membrane sheets used for a fully adhered system are not as wide as those used for a loose-laid ballasted system, and therefore require more seaming. The procedure for starting out your first roll is very much the same as the other systems, squared and parallel to an outer edge. As each individual sheet is laid, it is cut and trimmed to fit all penetrations and edges. The sheet must be set in a finished position before it is adhered. And remember, some membrane manufacturers require the sheet to relax a while. Once the membrane is adhered in place, it can no longer be moved.
Now it's time to apply the bonding adhesive, which usually goes on both the substrate and the membrane.
Standing on one side of the membrane, pull back and fold the sheet over halfway. Next, check with your supervisor for the rate of coverage and then apply the adhesive. It's critical to spread the adhesive continuously, leaving no dry areas. There are several methods to help you do this, including hand spreading, pressurized rollers, and powered adhesive sprayers. You can also use a drum-type adhesive spreader. A full pail of adhesive is set on its side in the spreader's carriage, and then the pail is punctured along one side. Tilt the spreader and roll it over the surface. See how the adhesive pours evenly? To spread by hand, pour the adhesive in ribbons back and forth across the substrate and the exposed underside of the membrane. Once you've poured the adhesive, take a heavy napped roller or squeegee and spread it back and forth until the substrate is fully covered. Generally, adhesive is applied to the underside of the membrane as well. A pressurized roller has its handle connected to a hose. The hose is attached to a pneumatic pumping device that pushes bonding adhesive from the pail through the roller handle and into the head of the roller. Make sure you read and follow the pressurized roller's operating instructions to save you time and trouble. A powered adhesive sprayer also uses a pneumatic pump to pressurize the adhesive through a hose and spraying wand. The adhesive is sprayed evenly over surfaces. Again, check the manufacturer's operating instructions. Always wear eye protection and take the precautions so surrounding property doesn't get covered by overspray.
Some single-ply membranes are fully adhered using hot asphalt or a polyurethane spray foam instead of bonding adhesive. You can learn more about these adhesives in other NRCA training programs. Now, let's continue.
Generally, the bonding adhesive is allowed to dry until it feels tacky. The drying time depends on the type of substrate, weather and wind conditions, and how evenly the adhesive was spread. Whatever method you use to spread adhesive, avoid getting it into the side lap. That will interfere with a successful seam bond. If you do get adhesive on the seam, you'll have to stop and clean the edges with solvent before the adhesive dries. Once the adhesive is dry, lift and fold the membrane into place. Work the sheet in smoothly to minimize air pockets, wrinkles, or buckles. A wide push broom will help you to smooth down the membrane. You can also use a heavy lawn roller. Now, fold the other half of the sheet back. Apply adhesive for this half and let it dry. Then, fold the sheet into place. Smooth over the entire sheet with a broom or roller. Continue to install the rest of the membrane following the sheet layout so that water flows over the side laps without bucking the seams. As with the other systems, complete the seaming and application of all flashings as the work progresses, and apply a protective surfacing if required.
We'll look at how to apply these surfacings in Part 6 of this program. Before we move on, though, let's quickly review what we've just covered.
You saw how individual sheets are laid, cut, and trimmed to fit, and several methods for spreading the adhesive efficiently and safely. And always wear the appropriate PPE.
So, keep up the good work and join me in Part 6.
The race is over in what seems like minutes. Every turn and straightaway tests the skill and nerve of the driver and the professionalism of his pit crew. It takes expert timing, careful preparation, and teamwork to put a winner on the track. One bad tire, a loose bolt, or a failed gauge can mean the difference between disaster and success.
It's the same up here on a single-ply installation. Preparation and safety are things you can't ever take for granted. In Part 6, you're going to learn about surface preparation and check out the safest and most efficient application procedures. You ready to begin? Well, let's go.
You've seen one of these before, a broom. The first step in a surfacing application is making sure the membrane surface is sufficiently dry and free from dirt, debris, or any sharp objects. If you're going to apply a coating, you may have to power wash the surface. If you're working in cold weather, make sure the surface is free of snow, ice, and frost. When single-ply membranes are coated with frost, be extra careful. They are extremely slippery. Now, let's review some basic safety guidelines. Remember to wear the appropriate personal protective equipment, PPE, when you apply liquid surfacing. A face shield, chemical-resistant work gloves, work boots, long pants with no cuffs, and a long-sleeve shirt will prevent most chemicals from being absorbed through your skin. Also, if you're applying liquid surfacing materials, you should have adequate ventilation to protect yourself from breathing hazardous fumes. If you are spray applying a liquid surfacing, make sure you also protect the building you're working on, its occupants, and nearby property. Close off vents, warn neighbors, and protect nearby property by laying down tarps. Make sure there are no vehicles parked nearby, and if there is any chance of exposing the public to hazardous fumes, cordon off the areas surrounding the building, especially areas that are downwind. When you've taken care of safety and property protection, you're ready to begin the surfacing. Start at the area of the roof that's furthest away from the point of access. That way, you will minimize the amount of foot and equipment traffic over completed areas and keep from trapping yourself on the roof. Be sure you coat all flashing areas as your work progresses. Also, be careful near perimeter edges. Don't spill liquid-applied surfacing over the side of the building. It's very difficult to clean up.
Now, let's become more familiar with some typical coatings and application methods.
Acrylic coating is sometimes used on single-ply membranes. Another type of coating is CSPE, which is resistant to heat, UV rays, and many chemicals. It is commonly used on EPDM to make it reflective. CSPE is also known as Hypalon, its trademark name. Before you apply a coating, make sure the membrane is clean and dry. You'll need to stir these materials thoroughly before applying them. Be careful not to let them freeze before application or curing.
Let's move on and look at the equipment you'll use to apply these liquid surfacings.
They can be sprayed on or applied with a roller, brush, or squeegee. Check with your supervisor for the manufacturer's recommended rate of coverage. To apply surfacing with a roller or squeegee, first pour the liquid in ribbons over the area you want to cover. Be careful though, you don't want to walk in the liquid when you're trying to reach with the roller. The idea is to complete small, manageable areas at a time. Start rolling or wiping the squeegee to spread the liquid. Cover a pre-measured 1 square area and check the amount of material used. You should have applied the amount specified by the material's rate of coverage. adjust the rest of your application to achieve the proper rate of coverage. Continue until the rest of the roof is complete, and don't forget the flashing as your work progresses. To use spray equipment, be sure you're properly trained, and operate the equipment at the correct pressure. To apply coatings with spray equipment, keep the nozzle parallel to the roof surface in a constant sweeping motion. If you don't keep the nozzle parallel to the surface, you'll end up with an uneven application. The spray equipment must be kept in clean, working condition at all times, especially the spray nozzle.
Well, that brings us to the end of this program. We've covered a lot of material, so let's take a moment and review.
In Part 1, you became familiar with the different components that make up single-ply systems and the materials that are used. And you saw how important it is to follow the specifications for each component of the installation. In Part 2, you learned how to perform a membrane or sheet layout and how to work safely as you pull out and lay down a membrane. You also saw how to follow the layout plan and cut and fit membranes around penetrations. In Part 3, you learned to install the loose-laid ballasted system and saw how to apply aggregate, protecting the substrate as you work. You also became familiar with different types of concrete pavers used as ballast and how they are installed. In Part 4, you learned how to install mechanically attached membranes and checked out different types of fasteners. Always follow the manufacturer's specs. In Part 5, you became familiar with fully adhered installations, learned how membrane is adhered to the substrate using a variety of methods and tools. Always remember to wear proper PPE. In Part 6, you learned about liquid applied surfacing, carefully prepared the substrate, applied surfacings at the proper rate of coverage, and took precautions to protect yourself and nearby property from spills and other potential hazards. Finally, you checked out the different kinds of tools and equipment used to apply liquid surfacings. Every generation of American craftsmen is part of a proud tradition. From the builders of early skyscrapers to roof mechanics who are out building and repairing America every day. Each of you makes a unique and lasting contribution. The will to keep on learning, the desire to succeed, and good old-fashioned hard work. That's what built America, and that's what will bring you success too.
You've taken another important step in building your own history of success. Whatever you want to achieve is possible. Stick with your training. Keep practicing each new skill and, above all, always work together safely as a team.